Hello everyone and welcome to second chapter of TMUA Simplified, which is polynomials. We have already covered quadratic function. Now let's understand polynomials in general, and you know we will be doing cubic of polynomial also and some higher degree polynomials also. Right. So let's start. When I say polynomial, so polynomial in general, if I want to write, so I write y is a function of x. Y is a function of x, which is, I say, a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2, and so on and so forth. a1 n minus 1 x to the power 1 plus a n x to the power 0, which is 1 only. So this is how I can generalize a polynomial of nth degree. This is nth degree polynomial. This is nth degree polynomial. Now the powers n, n minus 1, n minus 2 up till and so on, they are strictly non-negative integers. Non-negative integers. They cannot be in decimal, fraction cannot be negative for it to be a polynomial. So for polynomial, the powers of the variable x has to be non-negative integers. And what are a0, a1, a2? These are constants, right? These are real constants, right? So this is how we express a polynomial. Like quadratic also is a polynomial with degree 2. So I can write it as y is a function of x. Now, rather than, I can also write it as a naught x square plus a1x plus a2. So the moment I put the value of n as 2, so it will reduce to this, where a naught, a1, a2 are constants. Or I can also write it like ax square plus bx plus c, just to differentiate a bit. So a naught, a1, a2 are also constants, a, b, c are also constants. Doesn't matter much, right? So this is how we can express a polynomial in general of degree n, right? Okay. Now there's one theorem, the remainder and factor theorem associated with it, with polynomial, which is very important, right? Now what is remainder theorem? Now in remainder theorem in general, if I have to understand, so in number system, remainder theorem is defined as a dividend is equal to divisor into quotient plus remainder. So this is how we express remainder theorem. Now when is it used? It is used to obviously find remainders, or it is also used to find factors, right? So if I say x square minus 5x, for example, plus 6, when divided by x minus 4, what is the remainder? Now I can perform a long division method to find the remainder, as well as I can use this remainder theorem. Now, if I use the remainder theorem, so I know x square minus 5x plus 6 is the dividend, divisor is x minus 4, and into quotient plus remainder. Now, in order to get the remainder, I need to get rid of this term. And to get rid of this term, I have to make it 0. And how will I make it 0? By putting x equal to 4, as you can see. On putting x equal to 4, this will become 0. So if I put x equal to 4 on both sides, so I will be getting 16 minus 20 plus 6 is equal to 0 plus r. So I'll directly get remainder as 2. Right? So this is how I can get a remainder. So as a part of a process, rather than writing this equation again and again, what I can observe is that if I put the divisor equal to 0, the value of x so obtained after putting the divisor equal to 0, I'll put it back into the dividend in place of x, and the value so obtained will be the remainder. So 16 minus 20 plus 6, which is 2. So the same process can be done like this also. You need not to put up an equation. Obviously, you should know the basics of it. which I've told you. But once you have understood this, then you do not need to necessarily write the equation and perform this operation. So what you can easily do is put the divisor equal to 0. You will get a value of x. The value of x so obtained, put it back into the dividend in place of x, and the value that comes out is the remainder. So remainder is 2. Okay, right? Okay, very nice. Right. If I say x square minus 5x plus 6 when divided by x minus 3, what is the remainder? Same thing. So as a part of the process, I'll put x equal to 3 in the dividend. I'm going to get 9 minus 15 plus 6, which is 0. So remainder is 0. And when remainder is 0, so the divisor is the factor of the dividend. So that's why it's also the factor theorem. So in case on dividing an algebraic expression or a polynomial by another polynomial, which is the divisor, the remainder becomes 0, then the divisor is the factor of the dividend. So I'll say x minus 3 is the factor of x square minus 5x plus 6, or I can also say that x equal to 3 is one of the roots of this polynomial. So this is how I can use factor theorem and remainder theorem to find remainders or to find factors, which is very important. Okay, we often get a lot of questions in TMUA which are based on this concept, right? Okay, let's move forward. So when is it, see the type of question, I'm taking a very simple example just to make things clear for you. What type of questions you can expect in TMUA? I'm taking very basic example. I compiled a few questions in the exercise so you can go through them and apply it. So if I say that x minus 2 is a factor of, say, x cube minus ax square plus 2x minus 5, find a. So I have to find this unknown coefficient a. Now to find this, I know that x minus 2 is a factor of this. So on putting x minus 2 as 0 and getting x equal to 2, if I put it here, then the value of the remainder will be 0 since it's a factor. So if I put 2, I'm going to get 8 minus 4a plus 4 minus 5 equal to 0. In place of x, I have substituted 2 in this equation and I have equated equal to 0 since it's a factor. So 2 cube is 8, 2 square is 4, 2 into 2 is 4, minus 5 equal to 0. So I will be getting 4 minus 4a is equal to 12 minus 5 is 7. 12 minus 5 is 7. So here that will go there and it will be minus 7. So a becomes 7 by 4. So this is how I can find a. Right? Then there can be cases where two factors will be given of a cubic and two unknowns will be there. Not just a, there can be two coefficients which are unknown, and we can make two equations and solve them simultaneously. So these kind of problems, in TMUA are quite regular, and you should just need to know the process, and doing them is not a problem. Okay. Now let's move on to the cubic polynomial. Now, when I say cubic polynomial, so like I can write it as y equal to a naught x cube, a1 x square, a2 x plus a3, right? Derived from the nth degree polynomial itself. So if I put n equal to 3, I'm going to get this. But as in quadratic, we replaced a naught, a1, a2 by abc. Here also I'm doing the same thing. So it's ax cube plus bx square plus cx plus d. So this is cubic polynomial. It will have maximum of 3 real roots because the degree is 3. So if I equate it equal to 0, so I'm going to get maximum of 3 x-intercepts. So the curve of this, if there are all 3 roots are real and distinct, so I'm going to get this kind of a curve. So in this case, we have all 3 real roots which are distinct, which are unequal or distinct. So you get 3 different values of roots. I told you in quadratic also, roots means x-intercepts. X-intercept means where y is 0 and y is 0 is on the x-axis. So that's how we can find them, right? So, but there can be other cases also of a cubic, like Suppose I have a cubic like this. So in this, all three are real. All three are real, but two out of three are equal. Two out of three are equal. You can see these are this whenever a curve is touching, so it does not represent one root, it represent two equal roots. As in quadratic also we have seen earlier, so in cubic also there will be two equal roots and one distinct root, right? Then there can be a case when we have only one real root and two are imaginary. So the curve will be like this. So this root, there's one real and two imaginary. So they can be different cases, right? And rest, how to spot, how to figure out how many roots a cubic polynomial or a degree 4 polynomial have. We will cover that in differentiation also, because through maximum concept of maximum minima point of inflections and all, we can also figure out how many real roots does a cubic have, right? But right now, these are the three cases which can happen, right? Either all three roots are real and distinct, then three roots are real but two out of three are equal. All three can also be equal. Yeah, there can be a case when all three roots are equal. Curve will be very similar to this only, right? But in that case, all three roots are, they will be equal, right? Like for example, if I have x minus 2 whole cube equal to 0, so this is a cubic equation in which all the three roots are 2. So the polynomial will be very similar to this one only. But in this case, one is real, two are imaginary. In that, all three roots will be real. So there are different cases which you have to remember. Although it's not, knowing the graphs, you may argue is why do we need the understanding of graph, but in paper like TMUA, it is very important to understand the graphs. There are questions which are specifically graph based in TMUA, so you cannot ignore the fact that graphs are very important. Just solving will not help you, right? So let's move forward. So this is how the graphs of cubics look like. Now the next thing that we need to know is how to find roots of a cubic polynomial. So either I know one of the factor, then I can find the other two very easily. Or if I do not know, then I have to find the first root through it and try. So suppose I give you one equation. Equation is like x cube plus 2x square minus 11x minus 12 equal to 0. And I have to find the roots of this cubic polynomial. Now, if I know one of the factors, then again I can divide it by, I can perform the long division method and I can divide this cubic by that factor, and the quotient so obtained will be a quadratic, which on putting equal to 0 will give me other two roots. But when none of the root is given, then we have to go by the hit and trial process. And most often than not, you get one of the roots among 1, minus 1, 2 and minus 2 of these four values. Most often than not, I'm using, not always, but yes, this is the condition, this is an observation, not condition, which we have seen, that one of the roots you get one out of these four values. So if I put 1, so I'm going to get 1, 2, minus 11, minus 12, which will never become 0. Now if I put minus 1, I'll get minus 1 ka cube minus 1, minus 1 ka square will still be 1, so plus 2, minus 11 into minus 1 will be plus 11, minus 12, and this is, you can see, is minus 13 plus 13 becomes 0. So minus 1 is by hidden trial is one of the roots, so you can say x plus 1 is the factor. If minus 1 is the root, then x plus 1 is the factor of this polynomial, cubic polynomial. Now if I divide this cubic polynomial by this factor x plus 1, right, and perform a long division method, then the quotient so obtained will be a quadratic. On putting that equal to 0, I'll get the other two roots, which is a process, right, which is there in the book also, which you can follow. But there is another method which is called synthetic division, right, which is very important. It helps in saving some valuable time. So there's a way of doing it. Like the root that we have calculated by hit and trial is minus 1, so I'll put it here. and I'll copy down the coefficient A, B, C, D value of the cubic here. It will be 1, 2, minus 11, minus 12. Now just to perform this division, what I'm going to do is always copy down this as it is 1. Whatever the first coefficient, the leading coefficient, that is A, copy down that first as it is below. Now then multiply this 1 by this minus 1, the root, which is, so it will give me minus 1. 1 into minus 1 is minus 1. And you put it here in the next column under 2 to minus 1. Now add the two values, I will be getting 1. 2 minus 1 is 1. Again the same process, I'll multiply this value by minus 1 and I'll put it in the next column. 1 into minus 1 is minus 1. I'll add the 2, I'm going to get minus 12. And finally, I'll multiply this minus 12 by this minus 1 and put it here, so it will give me 12. So if I add, it gives me 0. So by doing this, what has happened is, right, I have obtained these three values. And what are these? These, on the top, the coefficients were of cubic, and these are the coefficients of quadratic, the other factor of this cubic. So I'm going to get x square, please, because a is 1, b is also 1, plus x minus 12 equal to 0. So this is how I will put this quadratic 0, and this will give me roots minus 4 or 3. So the three roots of this cubic is minus 1, minus 4, and 3. And if you're going to factorize it, so it will be x plus 1 into x plus 4 into x minus 3. So the same cubic polynomial that I have, I can factorize it like this. This can be factorized in this manner. So this is what, this is very important when it comes to TMUA, right? The other thing which you have to remember is, since we have three roots of a cubic, so the sum of roots of a cubic is given by minus b by a. Like in quadratic also it's minus b by a, sum of roots. Here also it's minus b by a, but the b and a have different meaning. B is the coefficient of x square and a is the coefficient of x cube. Then there is another term which is called product of roots, sum of roots by taking product of two at a time. So alpha beta plus alpha gamma plus beta gamma. So I'll have three such pairs, right? If we have three roots, three real roots, so alpha beta alpha gamma plus beta gamma, and this will give me c by a. And product of roots toward end will be minus d by a. Like the cubic that I gave you, x cube minus plus 2x square minus 11x minus 12 equal to 0. For this, alpha plus beta plus gamma will be minus 2 by 1, which is minus 2. Alpha beta plus beta gamma plus gamma alpha will be minus 11 c by a, and alpha beta gamma will be minus d by a, which will be 12. So these are the three results. So very easily you can find these, and there will be questions which are based on this. So do remember this result, it is very important, right? Then the next is cubic and higher inequality. So in cubic and higher inequality, what we do is, again, like quadratic inequality we covered, and I told you a thumb rule, plus minus plus through the graph itself. Here also, if I look at a cubic, so I know if I have three roots, so on the right of this right, obviously for a greater than 0, right, that means the leading coefficient, the coefficient of x cube should be positive, then only the graph looks like this. So on the right of alpha, expression will be positive. Say between alpha and beta it will be negative, and between gamma and beta it will again be positive, and less than gamma it will be negative. So if I put it on a number line, if I plot the roots, right, so it will be, suppose these are the three roots, say gamma, beta, alpha. So I'll say positive, negative, positive, and negative. Now this goes on for all the polynomials. Like for cubic there are 4 intervals. For degree 4, there will be 5 intervals like plus, minus, plus, and so on for every other polynomial. But generally, they test you till cubic, till degree 3. So that's, it's perfectly all right to remember it like this. Okay. So suppose you can find the factors, the above only, above, which is the example that we did earlier, like x square minus plus 2x minus square, sorry, x cube minus plus 2x square minus 11x minus 12. Suppose I say is less than 0, less than equal to 0. So here what I'm going to do is, again, I'll find the roots, and which I did. And the roots were, one of the root was 3, that were -1 and -4. This is, we just calculated above. So it's plus, minus, plus, minus, and negative. It means on the right of 3, when x is greater than 3, the expression is positive. When x is between -1 and 3, the expression is negative. When x is between -4 and -1, expression is positive, and less than -4, it is negative. And I'm looking for less than 0. Expression less than 0 means negative. So my solution will be x less than equal to 3 greater than equal to -1, or x less than equal to -4. So this becomes the answer. So likewise, we can solve, inequalities for, whatever degree we have, right? So may it be quadratic, may it be cubic, the process remains the same, right? Now there can be some other inequalities, like suppose I have a square on an inequality, and if I say greater than 0, now the point that I have a square on a factor, tells me to operate a little differently, right? Operate little differently. And how will I do it? First of all, I'll apply number theory, and number theory says that since all of them are in product, and since this is always positive, so for this positive value and the remaining expression to be positive, and I know this is always positive, a square value cannot be negative. So for this entire expression to be positive, since this is already positive, so the inference or the implication of this is x minus 3 and x plus 5 should be greater than 0, right? So what I'm going to do is, my roots are 3 and -5, so plus, minus, plus, as I've told you in the earlier chapters. So I'm looking for positive value, so x is greater than 3 or x less than -5. So this becomes my answer. So if you have a even power on a factor, so you can remove it. Why you can remove it? Because that expression will always be positive. So if it is always positive, I need not to consider it. Reason, on the sign of the expression on both sides of it will be same. So that's why it's no more a critical point. So that's how I can interpret it. So just to show it on the graph, just to make things clearer for you, I have one root 3, then 2 and -5. So the graph of this looks like it is positive and it goes like this. Now rather than going up, it goes down again and it's like this. So you can see that the expression is positive only when it is greater than 3 or less than 5. So this is how the graph looks like. So if you want to plot this expression on the your graphing calculator, although it's not allowed in TMUA, but just for your reference, if you put it on the graphing calculator, you'll see the graph like this, and you can verify that this is the nature, right? I hope you have understood this, right? Now, then we have inequalities like, suppose I say that x plus 3 into x minus 5 upon x plus 2 is less than 0, less than equal to 0. Now, this is a fractional form. So whenever we have inequalities in fraction form, again, we cannot cross multiply, because the rule of inequality says if I multiply a negative number, cross multiply a negative number, then the sign of inequality will change. So I have to make two cases, once when x plus 2 is positive and once when x plus 2 is negative, which will consume a lot of time. So what I can do is, rather than this, I can make the denominator positive by multiplying and dividing. So if I multiply and divide, so it will not make any difference to my expression, but what it will help me is that the denominator has become positive. Now I can safely cross multiply, 0 into anything is 0. So the implication becomes this. So always remember, whenever you're not sure of the denominator being positive or negative in an inequality, make it positive by multiplying and dividing. So again, we follow the same rule. Roots are 5, -2 and -3. So we have positive, we have negative, we have positive, we have negative. And we are looking for negative values. And negative value are x less than equal to 5, greater than -2. I'm not putting a equality on -2, although I put it on 5, because the denominator cannot be 0. So denominator cannot be 0 for a rational function. So that's why I cannot include -2, because -2 plus 2 will give me 0. So be aware of it. We never put a equality sign on the factor or the value of x from the denominator, right? Or x less than equal to -3. So this becomes the answer. So this is how we can solve fractional inequalities also and general inequalities also, right? Okay. Just one more case. Suppose I say I have this x into x minus 3 is less than equal to 1 by x. If I have an inequality of this form, never cross multiply again. Bring the expression to the left and then take the LCM, x square minus x plus 3, x into x minus 3. Now perform the same process, take it into the numerator, multiplying and divide by the numerator, right? And now I can cross multiply, right? So I have these three factors. Now the problem here is, and very peculiar thing, very something you have to observe this. This roots of this are imaginary since the discriminant is less than 0. So now what to do? Now the roots have become imaginary. So uh, I don't know how to proceed further. But if I go by the graph says that whenever, since it's a cup-shaped graph, a is greater than 0. So for imaginary, the curve is like this. It's always above the x-axis. And if it is above the x-axis, the expression will always be positive. And since see earlier the way we tackled for x minus 2 whole square, since it was always positive, this is a square value. Same thing I can say here, that this is, since it's always positive, so the implication of this is that the remaining expression should be negative for this expression to be negative. And if I solve it, so it will give me 0 and 3 by putting it on the number line. Obviously 0, 3, positive, negative, positive, but I will not include them since they come from the denominator. So that's why we will not include them. I hope you have understood the polynomials in equations and inequality. So these are the things and these are the applications which you are tested on. I have compiled few questions at the end of the exercise. Do go through them, and there are video solutions of that also. Right? I'll see you with the next chapter. Till then, take care, keep working hard.